explore the mechanisms of cell injury, but this time we'll go deeper, adding all those tiny but high yield details that any test likes to test. And to make it stick, we'll use our house village analogy picture again. So, mechanisms of cell injury. Basically, our cells follow six mechanisms. I'll take you along one by one. ATP depletion, the power cut. Think of ATP as electricity in the house. You could see here. Causes, it's due to hypoxia, ischemia, mitochondrial damage, and toxins. Early effects are sodium potassium pump failure, therefore, water sodium will rush in, leading to the swelling of the cell. And we have our CA ATPase pump failure too. Here, the calcium fled in, activating the destructive enzymes, and this will also lead to detachment of ribosomes from the RER, therefore leading to decrease in protein synthesis. Later, anaerobic glycolysis will increase, lactic acid increases, pH decreases, chromatin clumping happens, and glycogen stores gets depleted. In the analogy, power cut, so swollen messy house, if the electricity is restored soon, it's reversible. And next segment is our mitochondrial damage. So let's explore the power station. Mitochondria are the village power plants. If they are damaged, the whole system collapses. Causes may be intracellular calcium level increases, free radicals increases, ischemia, toxins, etc. Consequences are fatal. Oxidative phosphorylation decreases, ATP levels fall down, and this will lead to energy crisis. Abnormal oxidative phosphorylation. So here ROS production decreases, free radical increases, and then leakage of cytochrome C. This activates apoptotic caspases, leading to the boom. So if the power plant itself explodes, not only there is no electricity, but sparks like our free radicals also fly around everywhere, starting new fires. So that's it. And then we have our calcium influx. So imagine it like the flooded house. Normally, calcium is like pressurized water kept outside the house. Once the pumps fail, calcium floods inside. So, how? Sources. Due the extracellular influx release from SER and damaged mitochondria. Effects, it activates several enzymes like phospholipases. These damage the membrane. Proteases, these damage the cytoskeleton, endonucleases, DNA fragmentation, and ATPases. It worsens the ATP depletion. So now the house floods with muddy water that ruins the furniture, wiring, and even the house's blueprint, like as we see during our DNA fragmentation. And then we have oxidative stress and free radicals. So this is the short circuit fire. Free radicals are tiny sparks that erupted from the powerhouse. So these are reactive oxygen species like superoxide, hydrogen peroxide, hydroxyl radical, etc. So they are generated from mitochondrial leakage, radiation, inflammation, drugs, toxins, reperfusion injury. So here I mentioned about inflammation, right? So usually neutrophils have some reserve of ROS. They use these ROS, like these species, to kill the pathogen. But if there is a rupture in neutrophil membrane, or in that case any leukocyte membrane, these radicals escape out, damaging the cell itself. And mechanisms of damage. So lipid peroxidation of membranes occur. So here we could see the leaky walls. Protein oxidation. We could see the misfold proteins. That is, the blueprint is destroyed. And DNA damage, mutation, strand breaks, and defense system. So enzymes like superoxide dimutase, catalase, and glutathione peroxidase, and vitamins A, E, and C. These are like antioxidants. They help to get rid of these free radicals. But here the case is the case has already slipped out of hands. And the analogy is like a spark from the short circuit sets curtains, walls, and blueprints on fire. Antioxidants are antioxidants like C, E, and A vitamins are the firefighters trying to fight the fire with water hoses. And then membrane damage, collapsing the house walls. When membranes fall, the walls of the house collapses and everything inside spills out. So it's due to obviously the free radicals, toxins, complement system, phospholipase activation, etc. And the sites, it happens in the plasma membrane. So the contents leak, cell death markers in the blood like CK, troponins, AST, ALT attacks on them. So that's it, death. And mitochondrial membranes, so loss of potential, cytochrome C leaks, ROS leaks, yeah. And lysosomal membranes, hydrolytic enzymes are gonna leak, leading to autodigestion of the cell. So here the analogy is once the walls break, furniture, water, and people spill out into the street, the house cannot be saved anymore. And finally, DNA and protein damage, burnt blueprint and broken furniture. DNA is the blueprint of the house. Proteins are the furnitures and beams. DNA damage, it's like due to radiation, free radical particles, chemotherapeutic drugs, etc. If repair fails, it's gonna lead to apoptosis, and in most of the cases, the repairs will fail. And protein misfolding, genetic mutation or ER stress, this triggers the unfolded protein response and apoptosis. So here the analogy is if the house plans burns and furniture crumbles, you cannot rebuild the house even if the walls are still standing. So tying it all together, ATP depletion is the blackout, it's potentially reversible. Mitochondrial damage is the power plant explosion, is irreversible, it takes along the whole street with it. And calcium influx is the flooded house, ruining everything inside. Nothing happens to the street though. And yeah, it happens because the street is ruined. The water comes from the street, right? Yeah. And ROS, fire spreading from the sparks. And then membrane damage, collapsing walls, spilling contents. DNA or protein damage, the blueprint is destroyed, furniture is gone. So these mechanisms don't act alone, they interact with each other, pushing the cell from reversible to irreversible injury. So when we go towards the clinical correlations, ischemic heart disease, so here the ATP depletion happens, followed by CA overload and coagulative necrosis. Stroke, so liquefactive necrosis due to ROS, and it's supplemented by the lysosomal enzymes. And carbon tetrachloride poisoning, so here free radical damage, this will lead to fatty liver. And reperfusion injury, paradoxial ROS burst after ischemia. And radiation injury, so the double strands break. So finally, always ask, is there ATP left? If yes, it's reversible. If no, it's irreversible. Then the second question should be, is calcium flooding in? If yes, the damage is gonna accelerate. Then is the ROS controlled? If no, the fire is gonna spread. And are the membranes intact? If no, there's no point of return. So the house is gonna be lights off, water flooding in, sparks flying, walls cracking, blueprints burning. That's cell injury in a nutshell. And the sparks go hit all the other houses in the street, setting the street on fire. So yeah, that's it for the day.